So this video goes along with my series parallel solved video on AC theory, and instead of working every little thing out one bit at a time, I'm going to attempt to do it all pretty much in one go, or just a few steps using a Casio calculator with complex mode function. And just to start with, this is how you can make polar or rectangular the default answer mode, if you like, on your Casio calculator, as long as it's a calculator that has the complex numbers mode. This is how you change your default between polar and rectangular. So we're going to solve the whole circuit quickly with a calculator without writing much down. So these are the Z total values that we got in the last video. And what I'm going to do with my calculator is set it to 3 decimal places with the following keys. You don't need to do this, it just looks a little bit clearer on the screen. But even though it displays 3 decimal places doing this, the calculator retains all of the decimal places. So there's 1 over Z parallel. And I'll show you how to find Z parallel using a calculator. Because the total impedance is the series impedance plus the parallel impedance. So for the first 1 over, we need a bracket and a reciprocal x to the minus 1. And within that, we've got 3 more brackets with reciprocal powers, as in 1 over whatever's in that bracket. The third bracket here is 1 over ZC3. So there's the format, or the shape, if you like, of the parallel calculations. Then I'll just press right and right and right to get out of that power. And I'm going to add the Z series. Remember, we had a 1 kilo ohm resistor, a 0.33 Henry inductor, and a 1 microfarad capacitor. So that's ZR1. Then we're going to add the capacitor, 1 over 2 pi times 500 hertz times 1 times 10 to the minus 6 farads, J or I, don't forget the J. Press to the right, and then add the inductive reactance, 2 pi FL, 2 pi times 500 hertz times 0.33 henries, J, the complex operator. So that's the series part, and then I go back to the parallel part. Firstly, R2, which is 1000 ohms, pretty simple. This is where we put Z L2 C2R, but I'm going to go across and do ZC3 first. So capacitive reactance, 1 over 2 pi times 500 hertz times 1 microfarad J or I, and then go back to do the series within parallel part that was in origin, ZL2C2R. That's made up of these components. As we're adding them, you can do them in any order. So 0.1 ohms for R. And because they're in series, we add 0.33 henries is the inductor, so the inductive reactance is 2 pi F times the inductance with J or I on the end. And finally, the capacitive reactance of C, 1 over 2 pi FC J. Don't forget the J or the I or it won't work. Press equals, and it'll give us our rectangular form total impedance, which is pretty cool, really. Then to convert it to polar, to check how accurate it is in polar, press option, down, 1, and equals. So this is even more accurate than what we did in the last video because we haven't rounded at any point. That's our total impedance. And I've shown you the methods of finding Z parallel and all of the other things. So now we found the total impedance, let's work out the total current. and a few other currents and a voltage. Supply current is voltage over total impedance, 100 volts at 13 degrees divided by ZT. So that's 0.07819 with no phase because it's the reference vector on the x-axis. I just stored it into memory location A. You don't have to press equals, it's already there now. And just to recall it, you press alpha and A and then press equals if you want to show it's there. There's our 78 milliamps supply current. If we want to find Vx, the parallel voltage, we multiply the parallel impedance, which you can work out using the reciprocal formula, multiplied by A, because in memory location A, that's where IS is. Press equals, roughly 38.8 volts across the parallel branches with that phase. And I'm going to store Vx into memory location 2 so we can find the parallel branch currents without typing too many numbers in. Current through R2 is Vx divided by the impedance of R2. And that's what we worked out earlier. I'm going to work out the current through C3, and it would be good if you had a go at working out the current through ZL2C2R. So the current through C3 is Vx, which is stored in memory location B, divided by the capacitive reactance of capacitor 3. And finally, just to show you how to do it, we're going to find a voltage. We're going to find the voltage across L1. Voltage is current times impedance, so that's current, total circuit current, which flows through L1 is A, and then multiply it by 2 pi FL for L1. And there we go. So I hope this was useful. It shows how quickly you can solve these circuits if you set your calculator up right. Have a go at figuring out some of the other things for yourselves, voltages and the other current, ZL2C2R current. Like and subscribe, and thanks for watching.